Hi everyone. So today, by the end of this tutorial, hopefully you'll be able to graph any kind of polynomial. So by the way, when I say any kind of polynomial, I do have restrictions. So it needs to be factorized the way that these ones are, right? So basically you need to know the roots of your polynomials. Okay, so supposing that you already know the roots of the polynomials, I'm going to start graphing these three problems. So starting off with the first one, right? Let's do this. So let me just draw my axes. Right, the first idea, like I said, is to figure out what the roots are. Now the roots of the first question is x is equal to 3, 1, and minus 1. Okay, so you simply take the minus values of these things. So if it's a minus 1, my root is plus 1. When it's a minus 3, it's plus 3. The idea of roots is that when is this equation equal to 0? Okay, so that's what I mean by roots. Okay, so now that we know these my three roots for this question, let me just do this. I'm going to do 3, 1, and minus 1. So at these 3 points, it will cross the x-axis because my y is equal to 0 at that point. So for example, when I put x equals 1 into my question here, this part becomes 0, right? If this part becomes 0, the entire polynomial is going to be 0. Okay, back to the question. The next thing that I do is that I'm going to draw y equals x minus 3, y equals x minus 1, and y equals x plus 1. So just gently draw these three lines. Okay, so don't worry about the big polynomial, just draw these three ones for now. And then I break this up into 4 regions. So break it up along these along the roots, so you end up with 4 regions: 1, 2, 3, 4. Okay, all right. Now the idea behind this is that you count how many things are positive in each region, how many things are positive and how many things are negative. So for example, if I extend these 3 lines, right, that's a bad straight line, but you get the idea. So over here I have 3 positives. In this region I have 3 positives. When I multiply 3 positives, I will end up with a positive, right? So I end up with a positive in that region. So this region will be positive. This region over here, I have 2 positives and a negative. When I multiply 2 positives and a negative, I get a negative. So it's going to go like this. It must go through that line, so I'm going to curve it back up. Okay. Over here, what I'm going to remember is all 3 lines extended, so I haven't drawn that there, but it'll look something like that when all 3 there. So I have 1 positive and 2 negatives. What happens when I multiply 1 positive and 2 negatives? I get a positive. Right, remember the 2 negatives are a positive. And then finally, the last bit, I have 3 negatives. Alright, so that's my line. So I'll draw this one more time without all this clutter in there. So this is the question that I have. Y is equal to x minus 1, x plus 1, and x minus 3. So that's the question that I have. Okay, alright, so x equals 3, x equals 1, and minus 1. So now I'll gently draw these 3 lines rather than, okay, so now I need to, now in my head I'm going to think, when I extend these lines, right, are they positive or negative at the point that I need to think about. So in this region it's 3 positives, so I have it like that. In this, between 1 and 3, I have 2 positives and a negative, so it'll go underneath. When it's between minus 1 and 1, I have one positive and two negatives, so it'll go above. And the last one I will have three negatives, so therefore there you go. So that is my polynomial for this question. Okay, alright, next question. It'll be y equals x minus 3 squared and x minus 1 cubed. So this is slightly tricky question, x minus 1 cubed. So let me draw my axes one more time. My y-axis, my x-axis, not a good straight line. Okay, all right, so this time again I'm going to do the whole, my roots are at 3 and at minus 1. Oh, sorry, big mistake right there. It's supposed to be plus 1, right? So there you go, 1 and 3. That's my x, that's my y. Okay, now, yes, I have to make sure that the points go through here, right? But this time I have x minus 3 cubed. One idea is to actually draw x minus 3 squared, so I can draw two lines over here. Okay, that's the idea behind this. At x minus 1 cubed, I draw three lines, 1, 2, 3. Okay, so over here in this region, right, I have all of them are positive, so yes, it'll all simply be positive. Between this region, I have two negatives and three positives, right? So if I have two negatives and three positives, what is it going to be? It's going to be simply positive. All right, and remember I have to curve back down. I have to curve back down because it has to go through that point over there. So it's going to go through that point now. After that region, I have three negatives and another two negatives. So I have 5 negatives, which gives me a negative. Right. So let me run through that again. Over here in this region, I had 5 positives. 5 positives in this region. In this region, I had 3 positives and 2 negatives. So all of this gives me a positive. In this region, I have all 3 negatives and another 2 negatives, so give me 5 negatives, right? So yeah, everything beyond this region will be negative. Okay, now I want to redo this question again without thinking too much about this thing. We obviously need it, but just a little trick so that you can be a bit faster when we're drawing that. Okay, all right, now remember I had x minus 3 squared and x minus 1 cubed. Now whenever it's squared, really it's always going to be positive, right? Always going to be positive. So it doesn't really switch any signs. A positive times a positive is still positive. Positive times a negative is a negative. So multiplying by a positive isn't going to change the sign, right? So think about that. Multiplying by a positive number isn't going to change the sign. So all I really care about is that it's simply going to go through that line, and that's the only thing that I care about. Okay, and then when I come here, I have x minus 1 cubed. So the only thing that I'm going to care about is the fact that it's a odd power. So rather than drawing 3 lines, I'm going to draw just 1 line, right? Because remember, x minus 3 cubed can be written as x minus 3 squared multiplied by x minus 3. Okay, so remember what I said, that the square doesn't really do anything, right? It doesn't really switch any signs. So that's why I only care about the odd powers. All right, so now let's do this question. All right, so it's going to go through, so in this region, I only have one line, right? So it's positive. So it's going to go through that. It's still positive up to there. So I must go like this. And then the line becomes negative. So there you go. A much faster way of thinking about it. So just to summarize, all I really care is odd powers. Odd powers are really the ones that change when the polynomial becomes positive or negative. Alright, so wherever I had the odd polynomial, I draw just one line. Alright, whenever I have this even power, it's always going to be positive. So all I care is that it just goes through that point right there. Okay, so that's why I had to draw the 2 points, and then simply a matter of joining the dots. Okay, last question. So we're almost done. Last question, x minus 3 squared. Okay, let me write this down. So this goes y is equal to x minus 3 squared times x plus 5 cubed times x minus 1. I think that was a question, but anyway, that's the idea that I wanted to show. Now, you might be tempted to just jump into this question and cancel out x minus 3 squared with this x minus 3 at the bottom, and you can definitely do that. Okay, you definitely can do that. There's nothing stopping you from doing it, but there's a little thing that you need to remember, and that's x cannot be equal to 3. Okay, in fact, I'm going to do one more change to this question, and I'm going to make this a 2x minus 1. All right, just to make it a bit more interesting. So again, drawing my axes, my x and the y axes. Okay, now my 3 roots are x is equal to 3. So ignoring the fact that I can't be equal to 3 for now, right? The 3 roots are x is equal to 3 minus 5, and you need to be careful over here. Don't jump in and say it's just simply equal to 1. It's not. It's equal to a half. And the last one is a half. Okay. The reason is, when is 2x minus 1 equal to 0? It's equal to 0 when x is equal to a half, right? So yeah, there you go. Your 3 roots. So half, 3, and minus 5. Okay, the x plus 5, the root is minus 5. Okay, so remember, I'm only concerned about the odd power. So this is my odd power, and that's an odd power because it's power of 1 now, and that's also an odd power because it's power of 1. So basically, I'm going to draw straight lines that look like this at those 3 points. Okay, so in this region over here, I have 3 positives, right? It has to go through that point, so it's going to go like that. And then 2 positives and 1 negative, it's going to drop down below. And then in this region, I have 1 positive, this line over here, and 2 negatives, right? So I have a positive. And then last but not least, this region is going to be 3 negatives. All right. So to summarize, this one had 3 negatives. This side had 1 positive and 2 negatives. This region had 2 positives and 1 negative, and this side had all 3 positives. Okay, now coming back to this little guy over here, the only thing that's going to change is that instead of drawing a solid line at this point, I'm going to draw an empty circle. An empty circle to suggest that this point over here cannot be taken. Alright, so that's pretty important. So no, not a solid circle, it's an empty circle. Oh, my colors are going crazy. But anyway, you get the idea. That's supposed to be an empty circle. So yeah, there you have it. That's how you draw a polynomial. So just remember, in summary, it's really the odd powers that matter, and and you need to factorize it. You need to factorize it so that you find the roots. Okay, so if you have any questions, just leave any comments. Please give me any feedback. It will be really appreciated. So thank you.